Welcome to Working with Health IT Systems, HIT Facilitated Error, Cause and Effect. This is Lecture B. This unit will focus on error in health and healthcare that can be facilitated and propagated by HIT. Different classes of HIT errors, such as slips, mistakes, errors of omission, and errors of commission, will be discussed and differentiated. Specific scenarios that create opportunities for HIT facilitated error will be presented to students in the lab exercises. In these exercises, students will apply concepts learned in the didactic portion of the unit to identify error, classify error, analyze root cause, and propose solutions. The objectives for HIT Facilitated Error, Cause and Effect, Lecture B, are to cite examples of situations where HIT systems could increase the potential for user error, and analyze sources of HIT facilitated errors and suggest realistic solutions. There are several ways to define errors, and here are a few terms you should be familiar with. There are errors of omission and commission. According to the Joint Commission, an error of omission is defined as, quote, an error which occurs as a result of an action not taken. For example, when a delay in performing an indicated cesarean section results in a fetal death, or when a nurse omits a dose of a medication that should be administered, or when a patient's suicide is associated with a lapse in carrying out frequent patient checks in a psychiatric unit. Errors of omission may or may not lead to adverse outcomes, end quote. An error of commission is defined by the Joint Commission as, quote, an error which occurs as a result of an action that is taken. Examples include when a drug is administered at the wrong time, in the wrong dosage, or using the wrong route, surgeries performed on the wrong side of the body, and transfusion errors involving blood cross-matched for another patient, end quote. According to the Agency for Healthcare Research and Quality, AHRQ, quote, mistakes, on the other hand, reflect failures from incorrect choices rather than lapses or slips in concentration. Mistakes typically involve insufficient knowledge, failure to correctly interpret available information, or application of the wrong rule. So, for example, choosing the wrong diagnostic test or ordering a suboptimal medication for a given condition would represent a mistake, end quote. It should be obvious by now that HIT has been built by well-intentioned but non-clinically savvy people. There is a very interesting video called Oh Schnocks, which is a perfect example of this kind of confusion. These systems were built by very well-meaning people, but you will witness firsthand the frustration of a clinician who cannot figure out the interface with HIT. Refer to the work of Jacob Nielsen that we discussed in the unit about usability in HIT systems. In the Oh Schnocks video, we see the consequences of violations of those principles. Think back to those 6 usability components: learnability, efficiency, memorability, errors, satisfaction, and utility. Think about those things and then watch this video. How many can you identify? The Healthcare Human Factors Group from Canada's University Health Network actually produced this short and sadly funny video that gives those who watch it an idea of what it is like to deal with the technology frequently encountered in a hospital. These clips were taken in their usability lab where they observed clinicians working with the technology, the errors that occurred, and the frustration that ensued. Is all lost as we face poorly designed technology? No. As an HIT professional, there are ways to address the issue and to obtain a deeper understanding of the problems. As you are working with HIT systems, you may bear the brunt of user frustration as HIT is introduced and becomes a mandatory way of doing business in healthcare. You will need to get used to it, but at the same time be thinking about the solution instead of getting angry. Here's another video that deals with complex issues when dealing with humans. The long and the short of it is that if you don't understand how people will really use a system and you do not work with them from the get-go, and you do not design or buy a system that was built with the user in mind, you are going to end up with oh schnocks. As the HIT person, you will need to get used to users confronting you, asking questions like, why do I go to the start button in Windows to shut down? And other similarly baffling questions. It is your job to have a basic level of competency and literacy when it comes down to usability, so that HIT facilitated errors can be prevented from occurring in the first place. Watch how Mayo has addressed the complexity of trying to model users during the system's design process. How could you imitate what you see in the video in an office that is implemented in EHR? Of course, you may not be able to change something that is already in place, or a large system that millions of dollars have already been spent on to install, or you may not be able to alter the decision of an executive whose mind is made up. That does not, however, excuse you from not understanding the fundamentals and continuing to advocate for change and improvement. It may be best that you stop for a few moments, watch the video if you can, and then come back and finish the slides. Also on this slide, we have the formal definition of human factors from the International Ergonomics Association in 2000. Let's look at the definition on the slide. It says, quote, ergonomics or human factors is the scientific discipline concerned with the understanding of interactions among humans and other elements of a system, and the profession that applies theory, principles, data, and other methods to design in order to optimize human well-being and overall system performance, end quote. Think about these words, understanding of interactions of humans and other elements. Think back to the first material from Component 7 when we talked about systems and bottlenecks, and how an action in one area of the subway system can cause a domino effect in another area of the subway system. The same thing occurs in HIT. A misrepresentation or a typo or a seemingly innocent rounding up function in a drug calculation can be propagated across thousands of users with a single, simple keystroke. Human factors in HIT is equally concerned not only with the interaction amongst humans when they use a system, but also about the downstream effects. Ultimately, human factors is about designing HIT and only buying systems that have been designed with the user in mind, and those systems that have been built by those who both understand the system of healthcare and the downstream effects. This means that the product you end up acquiring and implementing is highly usable, and it results in high quality, efficient, and safe care. How can we help to avoid error in HIT? HIT can help to reduce error, but only if it is well designed and appropriate for the task at hand. Like in aeronautics, they learned very quickly not to put the eject seat button next to the emergency brake button. So we need systems that are easy to read, easy to understand, logical, able to support, not thwart, cognition, agile and flexible, help to prevent error, and make the right thing to do the easiest thing to do. This concludes Lecture B of Unit 6, HIT Facilitated Error, Cause and Effect. In summary, the question is it easy to assure usability and to build systems that support busy clinicians? Absolutely not. User-centered HIT design at this moment in time unfortunately does not get top billing. So you are going to encounter some really faulty products out there. You will see oh schnocks in real life, and you will have frustrated users barking at you. Having the fundamental knowledge of how HIT can prevent errors is just as important as understanding how it facilitates error. A knowledgeable HIT professional will be able to identify the issue before it emerges, or will be able to determine ways to address the aspects of low usability systems that actually spawn new classes of error. Your value as an HIT professional depends on your ability to help users make the best decisions. Whether this is in supporting usable systems that help them to do the right thing and prevent them from making errors, or helping them to inform purchasing decisions if you see something like this coming your way. Not a good idea, don't buy it. It may fall to you to identify areas where HIT error can creep in and actually diminish safety.